Welcome back to my Java series examples on Java collections and streams. Last time we saw a very simple example of reduce. Now we're going to go a little more deep into what is reduce. Preferably, so we're going to talk about reduce today. And
To
let's
talk
proceed.
about the reduce method in Java streams. What does reduce mean? Reduce means to diminish, lessen, or decrease in Java streams. It helps to aggregate elements. So, what does the reduce method aim to achieve? It simplifies and aggregates elements in a stream. Understanding the basics. The reduce method operates on stream object. So what are the sources? It operates on collections, arrays, IO streams, etc. What does it do? It performs a reduction operation. It aggregates elements into a single value key terms. Now, what does it have? It has an accumulator function, which is logic to aggregate elements, and then it has a associative accumulator. It's not just an accumulator, it's an associative accumulator. So now what is that? Let's see the method signature reduce. The signature of method is the output is optional to the reduce function takes a binary operator with accumulator. So what is this binary operator T? It's a functional interface defining the logic. Optional T encapsulates the reduce results safely. T is the type of stream elements. Example for a stream integer T corresponds to an integer. So this is, when you say just T, it's going to, typecast to that particular object. So this is the beauty of the T object. Associative function. So mathematics, you know what's an associative function. Grouping order does not affect results. Y A plus B open brace and close brace plus C is equal to A plus open brace B plus C close brace is an associative function because the result does not change. Similarly, this applies for multiplication. It does not apply for subtraction. What is an accumulative function? A function, what? It does something. It takes some inputs and gives an output. So what is an accumulative function then? It progressively adds or aggregates values. What's the purpose? Useful for summarizing data streams. What's the practical example of a reduce? So this is very important. This is where uh, we are going to write the Java code, and I'm going to take a stream of integer numbers, which is stream.off 1, 2, 3, 4, 5. What am I going to do here? I'm going to use the reduce function to get the sum of all these numbers. So how do I start? I will put binary operator integer instead of t. Now I put integer and I'm calling that as a summation function is equal to open brace. I have two elements. The first one is identifier, integer accumulator, and second one is integer element. And since this operates with the help of lambda, we use lambda in streams, right? So it has accumulator plus element. optional integer sum is equal to numbers dot, see numbers is stream, right? Numbers dot reduce summation function system dot out dot println sum plus sum. So you're going to get this sum here now. Let's break down the code. Stream sources, stream dot of 1, 2, 3, 4, 5. Binary operator is accumulator, current element, and use lambda accumulator plus current element. So adds each number progressively. The reduce method returns an optional integer containing the sum. Output is 15, right? So reduce simplifies aggregation in streams, works with associative and accumulative functions, ensures safe and flexibility. Reduction using optional T applications include summing, multiplying, or concatenating stream elements.
So let's take another example now. I mean, I'm going to take a similar example, but it's a bit different to have more understanding. And what I'm going to do is that I'm just going to make it very simple. Uh, the example what I show is a reduced example here, right? I'm just going to do a similar example, and I'm going to call this as reduce example 2. And here, what I'm going to do is that I'm going to have a stream of numbers. So how do I do this? So let's make a stream of integers, stream of integers is equal to stream dot with. Now I'm going to queue the integers 1, 2, 3, 4, 5. Now this is a stream of integers, and I need to import streams. It is saying to me that it needs to operate the streams. So streams is not getting recognized. So we have declared a stream of type integer. Let's give it a variable name like numbers. Now we did the first task in our slide. As per our slide, we prepared a source of stream. Now next is we are going to have numbers dot, because it's already a stream now, numbers dot reduce. So if you see reduce, right, reduce takes, you have more than one arguments of reduced. And what we discussed is we are going to take reduce with uh, binary operator, integer accumulator, plus an integer identity. So we're going to use identity here for initial value. Uh, and what is the output it gives? It gives me an integer. So let's try this one. So I'll use integer identity as 1. Then I will use, next is, let's not use identity in this case. Let's try without identity first. And let's see if that works for us. Dot re. And now we have to pass what? As per that slide, we have to pass a function to numbers.reduce. Let's come back to the signature of the method. The signature of the method takes an optionality. So I need to have an optional integer. Let's go back to our slide. And then what it does, it calls the reduce, and then it takes, we need a binary operator. So we need binary operator of integer. So as per the slide, we had an optional integer and a binary operator. Then we need an accumulate. So binary operator is a functional interface. So I will give a interface name summation, and what I will do is that function will take uh, input element. So now we have binary operator integer. Let's call that as a function. What does this function take? We are writing only a lambda operation right now. We are not passing to reduce. See, we have kept cell null, right? And it takes an accumulator of type integer, and it should always point to a current element. It takes two inputs, and then the operation is every time you add the current element to accumulator, and this is the function. It is showing this as, not identified. Import this java.util.function. Now it's showing as identified. Now pass this summation function here to the numbers.reduce. And when you pass this, Numbers dot reduce, it's going to take all your inputs. What remains is that you have to take the output of this and print it. So what if I say, so let's try to take an output of this, the optional sum, just to have safety, because so that you will not have a null pointer exception. Now, after doing this, we're going to print the number. Sum. Sum is, and let's execute this program. So just to summarize now that we try to understand uh, the reduce function today a bit deeper. We saw the structure or the signature. We got the answer correct. So let's try to summarize what we did today, uh, one by one. So we exactly saw what does reduce means. It means to diminish or lessen to one value. And then this reduce method works on stream objects. So it needs a source of stream. And the reduce method as the signature, right? It has accumulator function, and the accumulator is type associate accumulator. Then we are examine the signature of the reduce method. So the signature is, it gives me a optional t type. Here the option is integer. So you will see this, the output here is optional integer for numbers dot reduce. Now, when you see this optional integer, uh, what exactly happens is that it needs a binary operator, which is an accumulator. So we gave here, we declared a binary operator summation accumulation function, but the way we made this is that we gave the the first argument, it's integer accumulator, and then the integer current element. And then what operation we are doing here is that we are adding the current element to accumulator. It's not necessary to use a binary operator integer, give a summation accumulation function. You can directly write inside this number dot reduce the whole thing, which means that I can do this inside control X, and I can do control V, right? And I need not have this binary operator. It would still work. But to just make things simple, we had done this way. We had used a binary operator integer to make the code more readable. We used the binary operator integer. Coming back to our slide, binary operator is the functional interface defining the logic. So we are defining the logic inside the binary operator. It is we are defining the functional interface. Then we are defining its output. And then associative function. So when you make a binary operator here, and then you define the accumulation function, and then you pass this. So this is more, kind of defined way of defining a binary operator integer, summation accumulation function. And that is what we are discussing in the slide here of the accumulator function. We defined a functional interface. So let's put this as functional interface defining the logic. And this is our source of stream. The functional interface defining the logic. Then we are passing this functional interface to the reduce function. Passing the defined functional interface to reduce function, reduce method. Seems very complex. Try to understand conceptually that we can pass a functional interface to the reduce method of, okay, the functional interface is of type, it's a binary operator of type integer. If you understood this video, please hit the subscribe button or the like button. I'm going to conclude here. Give me a feedback. If you feel like having more examples on reduce, I can take it. Thank you all.